Okay. So we have a clinical trial test, a method designed to increase the probability of conceiving a girl. In a study of 642 babies were born, and 321 of them were girls. Use a sample to construct and interpret a 99% confidence interval estimate of the percentage of girls born. All right, so let's identify what we have here. In this case, we have 642 babies that were born. That's your sample size. So N is 642. And X, 321 of them were girls. X is the number of successes. That's 321. And we are constructing a 99% confidence interval. Okay, so that means we need to find out what our critical z-value is. And that is going to come from this table right here, the confidence levels and their critical z-values. So if it's 99%, that's one of the three most common critical values. 99% means that the critical z-value will have to be 2.575.
Will that be given to us?
Yes, yes. This, in fact, this entire help sheet will be given to you.
Okay.
All right, so the critical z-value is 2.575. Now, what we need is p hat, which is, of course, x divided by n. Because we know what x is, we know what n is. So if we do 321 divided by 642 in the calculator, what will we get? 1/2, or 0.5. (321) divided by 642, that's going to be 0.5. And if p hat is 0.5, then q hat will have to be 1 minus p hat. So what's 1 minus 0.5? Also 0.5, okay? So your p hat is going to be x divided by n, if x and n are given. And q hat will be 1 minus p hat. Now to find the margin of error, z of alpha over 2 is this, the square root of, z of alpha over 2 times the square root of p hat times q hat divided by n. That's how we find the margin of error. All right, so the z of alpha over 2, that's 2.575 times the square root of p hat, that's 0.5, times q hat, that's also 0.5. Whole thing's divided by n, which is 642. So here's how we compute that. 2.575 times, and then second x squared for the square root. 0.5 times 0.5 divided by 642. And then hit enter. Now let's say I want to round this off to 4 decimal places. That's going to be what? 0.0508. 4 decimal places. Okay, that's the margin of error. Now, since I have the margin of error and I have what p hat is, I can construct my confidence interval, which is this: p hat minus the margin of error, that's E, and that's going to be less than P, and less than P hat plus E. And then just substitute those values in. P hat, we found that out to be 0.5, minus the margin of error, that's 0.0508. That's less than P, and less than 0.5 plus 0.0508. Let's see, 0.5 minus 0.0508. Let's say I want to round this off to 3 decimal places, because it does say round to 3 decimal places in this problem. So 0.449 would be the lower limit. That's going to be less than P, and less than, let's see, 0.5 plus 0.0508. To 3 decimal places, that would be 0.551. So that's my confidence interval. Now, if we want to interpret this, we have to say something like this, that we are 99% confident, since we're constructing a 99% confidence interval, that and I'm going to say this, the true, and I'm just getting this from the problem, the true percentage of girls born falls between, and if we're dealing with percent, we need to change these decimal values to a percent. So what's 0.449 as a percent? 44.9%. And what's 0.551 as a percent? 55.1%. Now, if it says true proportion, then you'll leave it as a decimal. Okay, so that's how we interpret the confidence interval in words. Okay, any questions on problem number 1? Now, in problem number 2 is coming up with the required sample size. Here it says, find the sample size needed to estimate the percentage of adults who have consulted fortune tellers, and you're told to use a 0.08 margin of error, use a confidence level of 90%, and use the results from a prior poll suggesting that 18% of adults have consulted fortune tellers. Okay, so already we have a margin of error of 0.08. And we're going to be using a 90% confidence level. So we need our critical Z value for that. So we need to know what Z of alpha over 2 is going to be from that table. 90% means our critical Z value will have to be what? 1.645. Okay. And we're told to use the results from a prior poll suggesting that 18% of adults have consulted fortune tellers. That's your P hat. So what's 18% as a decimal? 0.18. If we know what P hat is, we can find out what Q hat is. That's always going to be 1 minus P hat. So what's 1 minus 0.18? 0.82. All right. Now, also on your help sheet would be this formula for finding the sample size required to estimate a population proportion. So I'm going to give you that as well. And I'll write that down. It's going to be n is equal to z of alpha over 2, and that's going to be squared, times p hat times q hat divided by the margin of error, and that's going to be squared. Now the z of alpha over 2, that's our critical value, or critical z value, which is 1.645. That's going to be squared, times p hat, which was 0.18, times q hat, that's 0.82. All that's going to be divided by e, which was 0.08. And that's squared. Okay. And if I did all that in the calculator, 1.645, and that's squared, times 0.18 times 0.82. Then we divide that by 0.08, and that's going to be squared. This is the value that I get, 66.4077. But we always round up to the next larger whole number. So what would be the next number after 62? 63. Okay, so to answer that question there, the sample size needed to estimate the percentage of adults who have consulted fortune tellers, we need 63 people in that sample. All right, any questions on example 2? All right, example 3. Problem number 3. The First National Bank is considering a survey of its customers to estimate the mean number of checks written per month. A sample of 36 customers was selected with a sample mean of 33.4 and a sample standard deviation of 11.2. Here we're going to construct and interpret, excuse me, a 90% confidence interval estimate for the mean number of checks written. So here we're going to be constructing a confidence interval estimate for a population mean. Because we're given the mean and the standard deviation. We're also given a sample size of 36 customers that were selected. The sample mean, which is X bar, is 33.4. And the sample standard deviation was 11.2. Now we need our critical t value. This is where table A-3 comes in. And we're constructing a 90% confidence interval. Well, there are two things we need to know. If we're going to use table A-3, we need to know our level of significance, which is the alpha. That's always going to be 1 minus your confidence level. So what's 1 minus 0.90? 0.1 or 0.10. Your degrees of freedom, which I call DF, is n minus 1. Sample size is 36, so what's 36 minus 1? 35. It's those two pieces of information that you're going to use to come up with your critical t value from table A-3, which will be provided on your help sheet. Let's see, do I have 35? Yes, I do. Here's 35. Now, in this case, we only use the area in two tails row. Just the area in two tails. And point 1 is right here. So if I read down and across from 35, I get a critical T value, which is what? What's that critical T value? I know that's hard to read, but it's going to be 1.6. Yeah, 1.690. I use that other T table that I gave y'all in class when we were doing this, because yeah, that reads much better. All right, so that's our critical T value. The margin of error is this, T of alpha over 2 times S, which is your standard deviation, over the square root of N, which is your sample size. Okay, that critical T value was 1.690 times S, which is the standard deviation of 11.2, divided by the square root of N, and N is 36. So we're going to do 1.690 times 11.2 divided by, and then second, x squared for the square root, 36. Let's round this off to 2 decimal places. That's going to be what? 3.15. So that's our margin of error. Okay. Since we have the margin of error and we do have x bar, we can construct our confidence interval estimate for the mean, which is this. X bar minus E, and that's going to be less than mu and less than x bar plus E. And here your x bar, that's your mean of 33.4, minus the margin of error, that's 3.15, and that's less than mu, and less than x bar, that's 33.4 again, plus E again, 3.15. So here, if I do 33.4 minus 3.15, that'd be 30.25. Oh, to 1 decimal place, what would that be? 30.3. Because the mean is to 1 decimal place, so that means our confidence interval limits will be to 1 decimal place. Mu less than 33.4 plus 3.15 to 1 decimal place. What would that be? 36.6. All right, so now if we were to interpret that in words, we would say something like this, that we are, and we're dealing with a 90% confidence interval, we are 90% confident that the true mean number of checks written per month falls between 30.3 and 36.6.
And then for this one, we're keeping those decimals out.
Yeah,
Oh,
because
I get it.
Because we don't change this to a percent, we're just dealing with the mean, okay? Okay. All right, any questions on problem number 3?
I have one question.
Yes.
So you said for 33.6, wouldn't it be 36.6?
You know, I thought I changed it. Well, okay.
I just have written with the correct top.
Because I've been sitting up here writing this stuff out and not changing it to the correct number. So it's 36.6. Okay. Any other questions on problem number 3? Okay, now problems 4 and 5 deal with hypothesis testing. Number 4 deals with the population proportion. Number 5 deals with the population mean. And they're both of one sample. And it says here, in number 4, a survey of 940 households showed that 158 of them used email. Use those sample results to test the claim that more than 15% of households use email. Use a 0.5 significance level. And of course, you're going to use the p-value method, which is the only thing that I talked about here. All right, so here we're going to follow that 8-step procedure. And this starts with, of course, step number 1 is writing the original claim in symbolic form. Now we're dealing with a percentage here, so we know we got to use lowercase p. All right, so how would I write the claim that more than 15% of households use email? How would I write that original claim in symbolic form? Okay. Well, let's look at this. It does say, here's the claim right here. More than 15%.
Greater than.
Greater than 0.15. Because you got to get this right first. Because if you don't, everything else is going to be wrong. Now, step number 2 is the opposite of the original claim. So that's my original claim. What would be its opposite in symbolic form?
Less than equal to.
Less than or equal to. So it'd be P is less than or equal to 0.15. Now, step number 3 is the null and the alternative hypothesis. So which one would be the alternative hypothesis?
P less than equal to.
Equals.
Well,
Equal to.
P is equal to, that's your null. But which is the alternative?
Not equal to 0.15.
Which one of these two?
Greater than.
Greater than.
Mm.
Again, you have to get that right too as well. And your alternative hypothesis is the claim. Because it's going to be one of these two. That will be your alternative hypothesis. The null always has the equal to regardless.
So how do you figure out which one is
The alternative hypothesis has either less than or greater than or not equal to.
okay. So it's not going to be greater than. It's not gonna...
No,
Okay.
not going to be greater than or equal to, because you can't have that in the alternative. Okay. In fact, if I can get to it, here it says so right here. Alternative hypothesis always uses either less than, greater than, or not equal to. Any other questions? Step number 4 would be the level of significance. What's our level of significance here? 0.05. That's given to you in that problem. All right. Now this is where step 5 and step 6 comes in, where we use our graphing calculator. All right. We have a survey of 940 households. That's your N right there, 940. And it shows that 158 use email. That's the number of successes, which is your X, 158. Okay. So, from the TI-84 Plus calculator, we're going to come up with Z. Here's how we do that. Press your stat key, go over to test. Now here, we're going to be dealing with Z-test. Okay, because that handout that you'll have has for proportion. You're going to choose one prop Z-test. One prop Z-test. Because we're testing a claim about a proportion. And then P sub 0 comes from the null hypothesis. In this case, your null hypothesis has P is equal to 0.15, so you'll type that in. X is the number of successes. That's the 158 that said they use email. Your N is the sample size, which was 940. And then for a proportion, it's either going to be not equal to, less than, or greater than. The one you want to select, you want to look at your alternative hypothesis. So we have to use greater than. Right arrow to that, highlight that, and then press enter. Then go down to calculate, make sure that the cursor is on top of the word calculate, and then hit enter. Now our Z value to 2 decimal places will be how much? 1.55, because the 2 remains. So our critical Z value or our test statistic is going to be 1.55. Now step number 6, also from the TI-84 Plus calculator. We can get the p-value. And I should say TI-84, not TI Plus.
When we're breaking down the problem, we don't have to put TI-84 on a test, do we?
No.
Okay.
So will you need to write down these steps to type in the calculator, or
No.
are you giving us that sheet?
You can use the sheet.
It's a sheet.
Is the help key, is it gonna have?
Yeah.
Okay.
Yeah.
Yeah.
Which parts are going?
It's up here.
Dang.
It's up here. Might not need the traditional method, but you're only going to use the p-value method anyway. Now for the p-value, which is just a lowercase p, what would that value be to, let's say, 3 decimal places?
0.60.
Yeah. So that's your p-value. Now, step number 7 is our decision rule. Since we're using the p-value method, it's going to be this. If the p-value is less than or equal to alpha, you want to reject the null hypothesis. So here that p-value, we found that out to be 0.060. And then the level of significance is 0.05. Is 0.060 greater than or less than 0.05? In this case, it's greater than. In this case, we failed to reject the null hypothesis. Now, step number 8 is using simple non-technical terms. We're going to address the claim, or write the conclusion to address that claim. And this is where the wording of the final conclusion comes in. In this case, the claim was the alternative hypothesis, but we failed to reject the null hypothesis. So that means here, we start by saying that there is not sufficient evidence to support the claim. And then finish the rest of it out. So here, there is not sufficient evidence to support the claim that, in this case, that claim was more than 15% of households use email. Okay. Are there any questions about problem number 4?
Will your alternative hypothesis always be like your original claim?
Not always,
Not always.
because sometimes if it says that exactly 15%, then this time your null hypothesis will be your claim. It's all about reading the problem. Okay. Any other questions? Okay, and finally, problem number 5. This one's testing the claim about a population mean. Says here, a researcher took a sample of 27 statistics professors and found that they had a mean IQ score of 119 with a standard deviation of 8. Use a 0.05 significance level to test the claim that the mean IQ score of statistics professors is greater than 115. And here we're going to use the p-value method on this one as well. So now we're going to write the original claim. Original claim in symbolic form. Now it does say a mean, so we know we're testing a claim about a mean and not a proportion. So we have to use the Greek letter mu. So what would be that claim?
Greater than 115.
Right. Because it does say that the claim was the mean IQ score of statistics professors is greater than 115. Now step number 2 is the opposite of the original claim. So if it's not greater than, then it must be
Less than equal to
less,
115.
yeah, less than or equal to 115. And then step number 3 is writing the null and the alternative hypothesis here. So which one of these two would be the alternative hypothesis?
Mu greater than 115
Hmm. And the null will have to be mu is
equal to
equal to 115. Now, in this case, our alternative hypothesis is a claim. Step number 4 is the significance level of significance, which is what? 0.05. And step number 5, let's see, we have a sample of 27 statistics professors with a sample mean of 119, sample standard deviation of 8. So from the TI-84 plus calculator, since we're testing a claim about a mean, we have to come up with our t-test statistic. So here's what we're going to do here. We're going to press stat, go over to test. All right, so here we're going to do just simply, I think it's going to be t-test. Yeah. Okay. So here we're going to do t-test, which is number 2. All right, now I'm going to highlight stats since we're dealing with some of these statistics here. So for stats, we go put the cursor on top of stats and then press enter. Mu sub 0 comes from the null hypothesis, which is 115. The mean, the sample mean in this case, that's 119. Oops. Gosh, let me try this again. Number 2. This should be 119. There we go. Standard deviation, that's your S, that's your 8. Sample size N in this case is 27. Okay. All right, in this case here, for the mu, we look at the alternative hypothesis, which is greater than. So greater than mu sub 0, we highlight that by pressing enter. Go to calculate, put the cursor on top of it, press enter. Our critical t value, not critical t value, your test statistic is what? Let's say the 3 decimal places, doesn't matter.
598.
Yeah, 2.598. Yeah. And that's because, if you were using the traditional method or the critical value method, then it would be the 3 decimal places because you have to compare those two. Step number 6, we find the p-value from the TI-84 plus calculator.
0.00, so 8.
Let's see, 0.00, and I'm going to say the 4 decimal places, 0.0076. Okay. And now step number 7 is coming up with our decision rule, whether to reject the null or fail to reject the null hypothesis. So if our p-value is less than or equal to alpha, you want to reject the null hypothesis. So the p-value was 0.0076. Our alpha level is 0.05. Is 0.0076 less than or greater than? Here is less than. So what would we need to do here? Reject the null hypothesis. Here we reject the null hypothesis. All right, we rejected the null hypothesis. The claim was the alternative hypothesis. So that means that there is sufficient evidence to support the claim. So we can say here that there is sufficient evidence to support the claim that the mean IQ scores of statistics professors is greater than 115. Okay. All right. So that's what we do in order to test a claim about a population mean. All right. Are there any questions about problem number 5? Or does anybody have any questions about what will be on Monday's exam?